Can you guys hear me?
Yes, sir.
I hope you guys can hear me now.
Yes, sir.
Yeah, Biswayan, your mic is on.
On my
Yeah, it's a new semester, but old problems with WebEx remain. There are 35, 36 responses for attendance. I think there should be more. Good morning, everyone. It doesn't feel like it's a new semester, right? Because uh, the gap was not too high. It looks like we were here only a few days back. Yeah, normally the first day of semester is you have a lot of energy and uh, it looks like things have changed. It looks like nothing has changed. This online mode sucks actually. Okay, so I'll wait for one more minute. So today's lecture is not really a lecture, it's more of a introduction to the course. So we can of course afford to uh, spend some more time on chatting and discussing and you may remember that in the previous semester uh, we used to have discussions. I said that one of the objectives that I have is to somehow uh, intrigue your interest in computer science. Okay, that is in my view that is one of the jobs that I have on my hand, that somehow I want you guys to become so self motivated that the actual um, teacher does not matter, right? I mean, you get motivated enough to learn on your own. So this was one of the intended uh, intended targets for me in the previous semester. I'm not sure how much did I achieve, but so in this semester you now have at least two programming subject. I don't know what other subjects do you guys have, but I know at least data structures is there and object-oriented methodology is there. I know data structures because initially I think it was probably offered to me or it's going to be offered to me. I'm not sure. But then I was asked to offer a object-oriented methodology, and I said fine. So we'll discuss more on how data structures and OOM, they are both programming related subjects, but they serve different purposes in your overall journey as a IT or computer science engineer. So they both have their own relevance, and as a student, you need to provide your attention to both of them. Okay. What other subjects do you guys have in this semester?
Other than data structures and OOM, we have professional communication, linear algebra and ordinary differential equations, and discrete mathematics.
Yeah, okay. So that is basically English, maths, and computer science. Yeah, so
Yeah,
that's pretty standard boilerplate for a CSE graduate. Um, and yeah, so discrete mathematics is also an important part. I'm not sure. Okay, the other one is linear algebra, right? So yeah, linear algebra. If you are planning to work in the field of machine learning, linear algebra is very important. So if your overall um, area where you are planning to work as an engineer is machine learning, please do spend significant amount of time on learning tricks in linear algebra. That is going to be a very important part. And if you are, for example, planning to work in fields like computer security and cryptography and stuff like that, um, then in that case, there is a part within discrete mathematics called abstract algebra. So please, give more time to abstract algebra, set theory, group ring field, these kind of things. Um, they'll be important for you from that perspective. So, and of course, professional communication. You guys know that it's more in the direction of developing your soft skills. So yeah, so I think the syllabus is good. Overall, the curriculum seems to be fine. And okay, I think how many people we have? 84. I don't think there will be any more. Uh, uh, I have 78 responses in attendance, so there are some people who might have not yet uh, ticked that. So please do that. So anyhow, let us start with the first just an introduction lecture. It's not really a lecture. There are some slides that I would like to show you. Okay, so this course is called Object Oriented Methodology. Okay, this is the name of your course. And so what you guys already know as of now is you probably have an introduction right now to the overall art of programming, right? And if you remember, in the first few lectures of ITP, I said that the idea is to teach you the art, right? I mean the verb, okay, uh, and because that is all that a teacher can do, right? A teacher can tell you different ways in which programming occurs. uh, to learn programming, you'll have to practice. Okay, it is very similar to mathematics in some sense, right? Someone can only teach you that these are the kind of theorems you have, right? But when to apply those theorems and how to use them, okay, uh, uh, this is up to you. Okay, you will have to figure out that when do you have to use one theorem over the other, right? When do you have to change, for example, sec to tan or sine to cos and stuff like that, or if you have two sides of a right angled triangle, how, which is the side that you have to figure out, something like this. It's very weird, but yeah, something like this. So similarly in programming also, um, as a teacher I can teach you some theory, right? Theory as in I can teach you what are loops, I can teach you what are conditionals, I can teach you what are functions, what are structures. These are general programming concepts. Okay, yes, we had a look at them from the perspective of C programming, because otherwise it will be too abstract without any practical knowledge. So we used C as the tool where we were trying to hone our skills using a particular programming language. But the overall idea was to teach you the art of programming. Okay, and this is why we started off with things like constants and variables, right? So we wrote some pseudocode algorithms and stuff like that. And the idea was that you have to get involved now in the area of programming. You have to start with uh, you have to come up with a new thinking process, okay, where whenever a problem is assigned to you, you have to think like, okay, what are the constants here and what are the variables here, and then if you have realized that these are the variables, you have to figure out, okay, well, are they characters, are they integers, are they real numbers, and sometimes you will also be required to group these variables together. So if they are of the same type, you might use arrays. If they are of different types, you might need to use structures. And then there are two important types of statements in programming, which basically is the crux of any program, right? I mean, usually a program is nothing more than a collection of loops and conditional statements. Usually, I mean, I'm not talking about very simple programs, but as you start growing as a programmer, you start your brain conditions itself to start thinking in terms of conditional statements and iterative statements. Iterative, of course, means loops, and a conditionals means if else, like kind of something like that. And then you also knew something like functions. So you said you realized that if a particular part of my program is going to be executed multiple times at different points of time, it probably makes sense to simply create a function out of it and then parameterize it. Parameterize as in the same code runs but with different data. And to do that, we had a look at custom functions. Pointers. So pointers as a concept is very important because you should understand how the background memory management is done. But most of the modern day programming languages, they actually take away the control of pointers, away from the developers, because pointers can, they are like a two-edged sword. You can do so much with them, but you can also easily cut yourself. So the idea is that you should at least know that this is how stuff works in the background. But more often than not, at least in unless you are uh, planning to work in, let us say, embedded programming, okay, where you program small electronic components, for example, using languages like Ada or C++, or C. Even there also they usually avoid using pointers. But yeah, the idea is that if you're, let us say, building a device driver, then you might use pointers. But otherwise, mostly you'll just need to know the concept of pointers, but nothing more than that. And of course, we did our labs in C. Some of you, in fact, were not too happy. You wanted to use C++ because from what I understand, you guys already know C++. So some of my job has already been done by your seniors, and the so but the reason I wanted you guys to start with C is because it's kind of a logical progression. Okay, when I say logical progression, it means that you basically start with a very basic thing, and you learn stuff at the lower level, and then as you go high, you can actually appreciate the higher level entities because of the way they are going to ease your life. So this is, in my way, the best way to learn something. This is why we started with operating system basics, and bash and linux and so on and so forth. The Even though you could realize that towards the end of the course we actually started using hacker earth, and in theory we could have simply used hacker earth from day one. But I wanted you guys to at least know how to operate GCC and some very basic bash. Okay, now it's up to you whether whatever you have learned in the previous semester you want it to be to get persistent in your mind, or whether you simply you learned and you forget. That is what you are planning to do. if that is the case, then certainly I cannot do much. But the idea is that you should get involved. Okay, start using a Linux flavor. Start writing code, and not just in on Hacker Earth. You also need to write code on your laptop, to build stuff. Okay, what exactly does it mean by building stuff, that we will see. So, first of all, whatever we did in the previous semester, that in you know you that can actually be loosely considered as structured programming or functional programming. So there are so many terms related to these programming, and none of them actually uh, are crisply defined. Okay, it's basically more of an idea. Okay, so structured programming, procedural programming, functional programming, um, these are all ideas. Okay, these are different uh, paradigms, I would say. They are not really very well defined, and it's sometimes it becomes really difficult to actually categorize a piece of code as one out of the n classes. But yeah, let me say that it's mostly structured programming, whatever we did in the previous semester. We used structures, we used functions. It can also be considered as procedural programming. um, but we did not, the reason we call it structured of procedural programming is because it was not object oriented programming. So why is this term important? Because um, as you actually start building stuff, okay, as you start doing more and more programming, you'll realize that almost all development that goes on today in software industry is in some ways object oriented. Okay, so this is why this paradigm of building stuff is actually more popular and probably more intuitive also. When we'll start using this, you will understand that probably object oriented programming is more intuitive, as in it relates to uh, the world around us in a better fashion. Okay, so we are going to basically build up on whatever we studied in the previous semester. So the first thing that you need to know is, whatever we did in the previous semester, we are not going to repeat that. Okay, because there is a lot of overlap between C++ and C. Okay, you guys have probably already seen that. You would have been doing C++ classes with your seniors, and we were discussing C in the class. So by now you would have already understood that there is a lot of overlap, and because of this overlap, we are not going to cover the things that we have already done. So I'm not going to teach you loops again. I'm not going to teach you conditionals again. I'm not going to teach you char and float double. There is a new data type that we will have a look, string. But basically that is just it, right? I mean, the basics, string and bool, but basics remain exactly the same, right? So we are not going to cover those parts. So in fact, what we will do is, uh, quickly in the next week, we will have a look at some of the basics of C again. Only those parts essentially. Maybe actually I should probably start it from tomorrow itself. We'll cover that part tomorrow, some basics of C, and then we will start with C++. But as I said, I'm not going to cover the parts which are going to be an overlap between C and C++. So in this course we are going to start straight away from classes. Okay, we'll know what classes are, but the idea is, whatever we covered in the previous semester, please revise it on your own. And in this, is similar to the previous course. um, we are only going to devote our time on concepts in the theory part. Okay, in your labs this time you are going to write code in C++. So you have to learn the programming art by practicing. Okay, I have a different way that I thought about in for labs this time. But the idea is you have to use the labs um, to to actually grasp the practical aspects, because in class, in the theory part, we are only going to cover theory. Okay. um, So this is an important slide. You guys have already seen what competitive coding looks like, right? Your seniors actually did a very good job uh, by indulging you guys with platforms like Hacker Earth so early in your programming journey, right? And it is good. Why? Because this is important for you guys from the perspective of placements. I understand that most of the companies these days, they actually use these platforms, and they ask you uh, they ask you to solve programming problems. And this is why uh, these platforms like Hacker Earth are so important. From the perspective of competitive coding, data structures, the other subject that you're going to study, that is actually very, very important, I would say, right? I mean, it is probably the most important subject in your whole curriculum when it comes to uh, placements. Okay, so from the placements perspective, probably data structures, and there should be another subject. I haven't seen your overall curriculum, but there has to be one course on algorithms, specifically one course on algorithms. Um, so data structures and algorithms, these are the two courses which are absolutely essential from the perspective of getting good placements, because they are going to train you for competitive coding. This course is more about system building. Okay, now what do I really mean by system building? When you actually join a particular firm, either for internship or as an engineer, when you join a particular firm, there they are not going to give you a programming problem in the form of a question where you have test sets and you simply have to write code so that the test passes. You'll be given a problem from the perspective of building something. They'll ask you to build a system for them. Okay, and usually these days, um, they look for what are known as full stack developers. So what do you mean by full stack developers? Basically, uh, they expect everything from one particular uh, hire, right? So essentially, they'll give you an end-to-end problem. You will have to figure out how to solve this problem. If the problem requires some graphical user interface, you will have to build it. If the problem requires storing some data, let us say in a database, you'll have to figure it out how to do it. If the problem requires communicating with other parts of the system over, let us say, a network, you have to figure it out how to do it. So this is the expectations from you when you go and actually join a company or do an internship. They will expect you to build a system. So this particular course is more on that lines, right? So this is going to be your um, first step in training you towards building systems. Now both these aspects are crucial, so don't ever think that they are basically complementary to each other. I have seen many students who feel that these two things are complementary. You only need to have one out of these two skills, and usually because of the placement thing, they actually feel that maybe doing better here is good. But I will actually show you a live example right at the end of this lecture of what happens to such students who focus only on this part, but they actually forget this part. Okay, so it is very important that you focus on both these subjects. They are both programming subjects. You are going to write code in both subjects. It's just that they are going to train you for different types of roles. Okay, they are this part is going to get you a job, and this part is basically going to keep you in the job. Okay, so they are both important. And I would say that probably this part is much harder, right? Because uh, it actually involves a lot of skills which are not straight away computer science skills. It involves learning how to interact with people. It involves coming up with design ideas. So in some cases, this part actually requires much more practice. for data structures and algorithms, there are so many resources on the internet. You can actually find so many websites which can train you for this part, but there are not so many resources for this. Okay, so if some of your seniors are, for example, participating in something known as Google Summer of Code, so GSOC is an example of this part. Okay, if you are participating in GSOC, this is what it is training you for. Okay, um, so let's have a look at what this course is all about. The major question that we will be trying to answer is this in this particular course is that how should we build a software system. Okay, I'll give you a very simple example why this part of the system is important. When you would have learned things like integration and differentiation, in the beginning it was just, you know what, a set of formulae, right? You would have realized that d dx of x to the power n is nx to the power n minus 1, right? And d dx of e to the power x is e to the power x, and something like this, the product rule and all those things. Um, but but exactly what was it, right? You may not have even appreciated, unless you might have done some problems on things like maxima and minima, right? That this is where you would have realized why do we need things like differentiation. That there is a function, and you need to figure out the slope of that function at a particular point. If the slope is positive, if the slope is negative, if there is a slight change in the slope, it is either a maxima or a minima, things like this, right? You might have done that in plus 2. But this is the idea, that now you can actually appreciate that all those formulae that you remembered, and you had to in the beginning it was just a memorization work, right? You had to remember how all those functions can be differentiated. But once you realize that this is why I actually learned differentiation, now you can probably appreciate differentiation better. The same thing is here, that when you'll start building systems, you'll realize all this programming that you are learning, right? What is the purpose of it? It is the major purpose as a computer science graduate is to build systems that make people's life easier, right? So this is the first step in your journey on how should we build a software system. Okay, and we will actually do some stuff that can be considered as designing or architecting a system. Okay, so let us say designing a system, or these architecture diagrams or design diagrams that you are going to prepare. In some ways they are actually equivalent to the algorithms and pseudocodes, right? We started with algorithms and pseudocodes because um, algorithms help you structure your thoughts better before you write some code. So similarly, we are going to do some non-coding activities in this particular subject, which are essentially a precursor to actually building a system. And we will learn some of these techniques in this course. And in addition, we will also do some stuff that is important from the perspective of building systems, right? So for example, you'll learn how to create network connections. You'll learn how to run some code in parallel. So till now, whatever code you wrote, it was like just one copy of the code that runs. But what if you want two programs to run simultaneously, or three programs to run simultaneously? How to do that? And we'll also look at some very basic GUI building, not in detail, but some very basic GUI building. GUI means some graphical user interface, some window that comes on top of your on top of your screen. So this is some of the knowledge that you will gain. And I have actually done this part. I don't think many would agree with me, not even maybe in your uh, in the the other faculty members might not even agree that you guys should do a project so early in your life, in your professional life. But I want to get you guys started with it, right? So we will do a very small term project means that towards the end of the of the course, I think for last 2 or 3 weeks, So we'll stop with all the studying part at least 2 to 3 weeks before, and then in the last 2 or 3 weeks I'll give you guys a kind of a running assignment, or an assignment that runs across 2 or 3 weeks, where you actually build a project. Okay, this is like a small software system. You will build everything from scratch to the, you know, to the finishing point. So this will give you a good idea, and you will basically pick probably one of these tasks. Okay, not all of them, but say you will pick up a particular project which involves doing something out of these three, and then you will try to build an end-to-end system with the help of it. So this is the overall idea of this course. This is what we are going to do in this course. So this is the part that probably you guys may have been interested. How would the evaluation work? Now, I actually did not have a good experience with shepherding last time. Um, it was a mixed response. Many of the students, in fact, I could see that people were not happy with shepherding right after I sent you guys the marks for class participation. A lot of people thought that class participation marks were not calculated in a justified fashion. Um, I did explain the reason for it, but still, like, I kept on getting emails that we are not happy with our class participation marks. So I thought, there's no point of doing something that you guys are not happy with. So I have done away with the shepherding. So now, all those choices that I gave you guys in the previous semester, all those choices are out. This time we'll only have live lectures. Of course, I will share all the recordings of the lecture on the Google Drive and YouTube channel, but there is no concept of shepherding this time. There will be live lectures like this one, and the actual evaluation will be something like this. There will be some surprise quizzes, and this time they will be really surprising as in, I'm not going to give you a hint that they are coming up. They'll come up any day. If you miss it, you miss it. It's simple. There is no no uh, alternative to it. 20% would be for your term project, the project that I talked about just now. 30% for mid semester, and 40% for end semester. So this is your overall evaluation. So at the end of this course, you will get these 4 marks. Okay, 4 set of marks, and that is basically your overall score. I will have to take attendance. I am not a fan of taking attendance, but basically I've been told that it is an academic requirement for instructors to take attendance, and this is why I'll keep on taking attendance. But attendance do not have any weightage in the evaluation. So it's up to you, right? I mean, I just have to report the attendance to the authorities, so I will have to take it, but they do not have any associated credits with it. Okay, this is the more interesting part. I realized that the labs may have been much harder for let us say a big chunk of the class in the previous semester. And I mean, I was hoping that by putting you guys into difficult situations, you guys might learn. um but I don't know whether it was helpful for you, whether it was too much stress. So this time I have changed the mode of lab. Okay, throughout your semester there will be 4 lab exams, and their dates are pre-decided. Okay, so I don't need to hear things like I can't do it because of this, or I can't do it because of that. These are pre-decided. You have to plan your personal life accordingly. Okay, that there are no, see, absolute emergencies I can understand that there is really no way you can avoid it, and this is why I will allow you to miss at max one out of these 4. Okay, so I will basically count the best 3, just like we had an n minus 3 thing. This is basically n minus 1, where n is equal to 4. Okay, so and these will be, if there is if the timetable doesn't change, because it happens very often here, and the labs remain on the days that we have been allotted for now, then it will be on these exact dates. Okay. And I'm announcing them beforehand. I don't want anyone to say we did not know that. So these are 4 lab exams that you will have. Lab exams will be exactly how they used to be in the previous semester. I'll give you a problem, you'll have to solve the problem, and then a TA will take a viva based on whatever you have done. So that is basically what we will do in the lab. These are the 4 exams that you will have, and your final score will be decided by the best 3 out of these 4 scores. The other labs that you will have, okay, they will basically be practice labs. Okay, so what happens is I will give you a problem, but it's not necessary for you guys. So because I know many of you are already good enough in C++, okay, so that is just a kind of time wasting activity for you, doing these labs. So in those labs, only those students who are, for example, weak, or who would like to practice more, they can join these labs, the usual practice labs. I will give you a problem, but it is not necessary for you to solve and submit it. Okay, if you do, it's of course good, but otherwise the idea is that you basically engage your TA. Let us say you are typing some code, there is some error, there is some problem. You engage your TA, you ask your TA to help you out, to get you out of that ditch. So that is the idea, that in usual labs it is basically for you to practice. I'll give you a problem, but and usually the problem will not be that hard. The idea is that you type some code, and if you get stuck, you ask your TA. That is the idea. Okay, so and there will be no viva as such. It's more of a practice lab. You take, and the good thing is we've got probably more TAs this time. So from what I understand, there will be around 7 TAs per batch. So if your strength is what, around 100, 115, 120, I'm not sure of the total strength, but it will be around somewhere that, right, the 115 or 120. So it will be what, 105 is 15, so some 16, 17 students would be there for per TA, right? And I'm assuming that maybe not all of you would be willing to join the practice lab, so I'm keeping the number at somewhere around 10 to 12. So some 10 to 12 students will be there with a particular TA for 2 hours. It is akin to some kind of a homework lab, where you try to solve a problem. If you get stuck, you ask your TA. The TA will help you out. Okay, it's not an exam. It's for your practice. So this is the idea of evaluation for labs. Okay, we will start from tomorrow. If you guys have any questions, you can ask, but before you have any questions, let me just show you. Okay, please ask your questions first, and then we'll come back. Let me see the chats. So Sahil, all the other labs are practice labs. I think we have something around 13 or 14 weeks in total for teaching. So other than those 4 weeks, yeah, every week you will have the lab slot. Every week is basically a practice lab. Other than the dates that I mentioned, on those dates it will be a lab exam, but other than those dates it is a practice lab. It is up to you whether you want to join it or you don't. You basically interact with the TAs, you try to learn. That is the idea. And these lab exam dates, they are predefined, that on these days we will have a lab exam.